Hello calculus students. In this video I want to just go over the idea of shifting indices on an infinite series. So we know that a series which is the sum from n equals 0 to infinity of a sub n means that we get a sub 0 and we add a sub 1 and we add a sub 2 and so on. Okay, and the idea here is that we look at the bottom number here, so we first plug in 0 for n, and that's how we get a sub 0. And then we plug in 1 for n, and that's how we get a sub 1. And then we plug in 2 for n, and that's how we get a sub 2, and so on and so forth. Okay, well, what if I don't want my series to start at 0? So I don't want to think about the first term as being n equals 0. What if instead I want my first term to be n equals 1, and then my next term n equals 2, and then my next term n equals 3? Well, the actual terms themselves don't change, right? This is a0, this is a1, this is a2. Okay, because I don't want to change my series, I'm just changing the way I think about it. So then what I'm thinking is, okay, well, if the index here is 0, but n is 1, then I want to think of this as 1 minus 1. Here, if the subscript here is 1, but my index n is 2, I'm thinking of this as 2 minus 1. And here, the 2 I can think of as 3 minus 1. And so I can rewrite this series as the sum with n starting at 1 and going to infinity, and now my term is not a sub n, it is a sub n minus 1. So that when I plug in 1 for the first term, the subscript here is 1 minus 1, which is 0. Okay, similarly, I can actually just make this series start at whichever index I want. Okay, so say I wanted, for some reason, I wanted my series to start at n equals 7. Okay, so I want this term to be 7, this term to be 8, this term to be 9, and so on. Well, then how am I going to write the subscript? 0 is 7 minus 7. 1 is 8 minus 7. 2 is 9 minus 7. And so I end up with the sum from n equals 7 to infinity of the term a sub n minus 7. Okay, so these are a couple examples. Now, what general rule can we figure out? Okay, to go from the original series to the one where we started with n equals 1, we changed two things. We changed the number that the index starts with, and we changed the subscript on the a. Okay, so specifically, we added 1 to the number that shows up below the sigma, and we subtracted 1 in the place where we saw an n in our term. Okay, what did we do to get this second version? Well, to get from 0 to 7, we add 7. And then to get from subscript n to subscript n minus 7, we subtract 7. Okay, so the whole idea is whatever you do to the number that shows up below the sigma, you do the opposite to every place you see an n in the term. Let's look at a couple specific examples. So the first one, I have the sum from n equals 5 to infinity of the term 3 divided by n minus 4 to the 4th power. Okay, so I'm going to change this, okay, and I'm also going to let you know some of the motivation about why I might change it. So I wish that this didn't say n minus 4. I wish that this said n. Okay, well, how am I going to get it to say n? I'm going to replace the n by n plus 4, so that when I have n plus 4 minus 4, the 4's cancel out. Okay, let's see, in other words, I'm going to add 4 here, which means to make up for it, I need to subtract 4 here. Okay, so my series becomes the sum from n equals 1 to infinity, and it's 1 because I thought 5 here minus 4 to get 1. And my term now is 3 divided by n to the 4th power. Okay, if you want to double check yourself, you could just write out the first term or two. So here the first term is n equals 5. That gives us 3 divided by 5 minus 4 is 1 to the 4th. The second term is n equals 6. That gives us 3 divided by 6 minus 4 is 2 to the 4th. Okay, and then if I look at my new version, my first term is n equals 1. Plugging 1 in here, we get 3 divided by 1 to the 4th. And then my next term is n equals 2. Plugging in 2, we get 3 divided by 2 to the 4th, and so on. Okay, and then we notice that these, when we write it out, write the series out the long way without using sigma notation, are equal. Okay, let's look at this second example I have written down. Okay, I have the sum from k equals 1 to infinity of the term x to the power 2k plus 10 divided by k plus 5 factorial. Okay, so here, something I might want to do is look at this k plus 5, right? And if I shift that, I can write it just as k instead. Okay, so what I'm thinking is that I wish this were just k rather than k plus 5. Okay, so that means that in my term, I'm going to subtract 5 from each place I see a k, and right here I'm going to add 5. So let's just do a little bit of scratch work. This exponent, if I subtract 5 from the k, becomes 2 times k minus 5 plus 10, which is 2k minus 10 plus 10, which is 2k. I guess just to be super thorough, the k plus 5, if I subtract 5 from the k, becomes k minus 5 plus 5, which of course is just k. All right, and so my series becomes the sum from k equals, well, I have to add 5, so I'm thinking 1 plus 5 is 6. So k equals 6 to infinity. In the numerator, I have x to the power that I figured out here, 2k. In the denominator, instead of k plus 5 factorial, we have k factorial.